Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to continue with the amines chapter, that is from 12th standard organic chemistry. Okay, so last time in this part we have seen about the basic introduction of amines, and along with that the preparation of amines. Okay, so today we will continue with the physical properties of amines. If you talk about the state of the amines, then lower amines are they are gaseous in state, meaning their particles are in random motion. Okay, so that's why they are gaseous. The intermolecular forces are weak, so they are gaseous in state. If you go to higher amines, then they are liquids, and the above that they are in solid state. Okay, then lower aliphatic amines, they are soluble in water. Okay, now as we have discussed in our previous parts also, why they are soluble in water, because they have tendency to form hydrogen bonding. So if you take suppose one example of amine, that is CH3NH2. Okay, so this is a primary amine, that is a lower aliphatic primary amine. Here we can see that there is hydrogens attached to the nitrogen. There are two hydrogen attached to nitrogen which are responsible for the hydrogen bonding, and that's why you can see that is a solubility in water. But one thing you will notice here, as you increase the molar mass of the particular amine, solubility decreases. Now why solubility decreases? Because when you increase the molar mass, what is increasing here? The hydrophobic part is increasing. Hydrophobic means which will not interact easily with water. So that's why our R group, okay, if you increase the molecular mass, it will be not soluble in water, the solubility will decrease. Okay, then primary and secondary amines are involved in intermolecular association. Okay, so let us see what is this intermolecular association. If I have this particular group, this is a primary amine. Okay, one more primary amine I will draw here. Okay, so if this is one of the primary amine and this is another primary amine, you can see that there is a hydrogen bonding between the nitrogen of one amine and hydrogen of another amine. So this type of bonding you can see. Okay, this type of bonding we can see here. Then if I have another amine over here, that is R and HH, then this N and this H can form bonding. So you can see there are intermolecular hydrogen bondings between nitrogen and hydrogen in the primary and secondary amines also. Okay, in primary and secondary amine, this hydrogen bonding can be seen because there are hydrogens attached to the nitrogen group. Okay, that is CH3NH2 or CH3 2NH. So this is example of primary amine, this is example of secondary amine. Okay, but we cannot see this intermolecular association in terms of tertiary amines, and the reason is there is no hydrogen present in tertiary amine. So general formula of tertiary amine is R3N. Okay, that means here there are three R groups, alkyl groups attached to the nitrogen, and no hydrogen is present directly attached to the nitrogen. So that's why this intermolecular hydrogen we cannot see in the tertiary amines. Next is chemical reactions. That is, first we will see basic character of amines. When amine is reacted with halo acid, that is hydrogen halide, we get ammonium salt. Okay, and similarly when we take aromatic amine, that is aniline, and react it with HCl, that is hydrogen halide, we get benzene ammonium chloride. Okay, and when we take this salt, the particular salt that we get after adding the acid, we with base, okay, this salt when we add with the base, we get our original amine again. Okay, that means this arrow can tell you that this reaction is reversible, and you get the you get your amine, that is whatever you had taken as a reactant, you get that again. That is, here we had taken RNH2 primary amine to produce the ammonium salt, and that salt we are reacting it with a base to get again the RNH2 group. Okay, so if I take example over here, CH3 NH3X plus OH minus gives CH3 NH2 plus H2O plus, okay, in place of X we can take Cl here, Cl, so here also Cl. Okay, then structure basicity relationship of amines. First we will see about alkanamines versus ammonia. Okay, alkanamines, now this is primary amine. Okay, and when we add a proton to it, when we when we remove a proton from it, uh, what happens? See here we have RNH2, that is a primary amine. We are adding proton to it, we are getting this particular structure. When you have just NH3 and we are adding proton to it, we are getting this NH4 plus structure. Okay, now here we have to determine who will be stronger base among this, whether the primary amine or the ammonia. Okay, now it will depend on what factor or which factors are responsible for their basicity. So here we have RNH2 group. We know that R is electron donating group. Okay, alkyl group is a electron donating group. So if you consider this particular structure, then this R group is attached directly to the nitrogen, okay, which is electron donating. It will give the electron to nitrogen. So if this R alkyl group is giving electron to nitrogen, it will be easily giving its proton to another compound or another atom. Okay, so here the ease with which it will give the hydrogen will be more. Why? Because R group, that is alkyl group, is the electron donating group. So if nitrogen is receiving electrons, then it will easily give the hydrogen to any other atom. So here there will be more basicity. This is having more basic character. And basic character depends on what? It depends on with how much ease you are giving the electron pair. Okay, in second case, here we are having all the hydrogens. Okay, and all hydrogens are having same character, so there is no electron donating group as such over here. So there will be, when nitrogen is giving its electron pair to any other atom, it will be not giving with that ease as in the case of RNH2. Okay, so that's why in second case there will be basic character which will be less. Okay, so in RNH2 the basic character will be more as it is having the R group attached to it. So on that basis we will see in gaseous phase. In gaseous phase, what will be the order of amines in terms of basicity? So we can see that tertiary amines are more basic than secondary, then primary, and last is ammonia. Okay, and why this is so? Because this is telling us the ease with which they can give the electron pair. So in tertiary we can see there are three alkyl groups attached to the nitrogen. So three alkyl groups means three donating groups which will give more give the electron pair with more ease than the secondary, primary and ammonia. Okay, so that's why in tertiary the basicity is more than secondary, then primary and then ammonia. Okay. So here what you have to understand is with how much ease you can give the electron pair. Okay, so tertiary is more than secondary. Secondary will be R, N, H and R. Okay, so here then primary is NH2 and R, and then NH3. In all the three or four cases we can see that this is having more donating group, so it will give more electrons. Okay, now second, in aqueous phase. Aqueous phase means what? Here water will come into picture. So if water is coming into picture, there will be bondings which will be which will generate between the amines, whatever we are putting in water and the amines. Okay, so here not only the electron donating group will be shown, but other effects will be also seen over here, and those effects like here we have seen inductive effect, okay, but in this case we will see the solvation effect. Even the steric factors will come into picture. So we will see how this other factors affects the basicity of the amines, okay. So if I take primary amines, or if I take the salt, okay, primary ammonium salt, then I have this kind of structure RNH3, okay. So this is having plus charge, okay. So if I put this in water, then I am having 3 hydrogens attached directly to the nitrogen, which will form bond with water molecule, okay. OH2 is water, meaning I have written it in opposite way. H2O, in place of H2 I have written OH2, because O is bonded to hydrogen, okay. So here in primary amine, the salt of amine, we can see that there are 3 hydrogens, so bonding strong, hydrogen bonding will be strong in case of the primary amine. In case of tertiary amine, we can see that there are 2 hydrogens which can form. In case of secondary, we can see that there are 2 hydrogen which can form the bonding with water molecule, and in case of tertiary, we can see that only one hydrogen can form the bonding with water. So decreasing order of extent of hydrogen bonding and order of stability. So here, who is more stable? The first one, because it is forming more hydrogen bonding, as there are 3 hydrogen present in that, okay. In second one, there are only 2 hydrogen, which will be less stable because there are only 2 hydrogen bonding, and in third case there is only 1 hydrogen bonding. So this is the order that we can see in the aqueous phase, okay. So in amines order, the solubility order of amines or the basicity order of amines in aqueous phase and the gaseous phase is different from each other, okay. It's not the same. Also in this, there is one more factor which is called the steric hindrance, okay. Steric hindrance. What is steric hindrance? Steric hindrance means when there are more groups, more bulky groups attached to the atom, then it will not give the compound to react easily with the with other compound, because there are more bulky groups attached to it. So it will cause the steric hindrance, okay. So this is called as steric hindrance. So there are 3 factors which are responsible for the basicity of amines, which are steric hindrance, then inductive effect, and solvation effect or solvation factor, okay. So considering these 3 effects, we can write the order of the respective amines, okay. Then next is aryl amines versus alkyl amines. Aryl amines versus ammonia. So here aryl amines means what? Aryl amines means when amines is attached to the aromatic ring. So if you consider NH2, that is aniline, the name of this compound is aniline. Here we will see the resonance structures of aniline. Okay, so as we know how the other resonance structures form, see here lone pair of ammonia or the amine will go to the next bond which is attached to the benzene ring, and then the corresponding double bond will shift to the next carbon. Then we will get negative charge on that carbon, and there will be double bond between the carbon and nitrogen atom having plus charge on nitrogen. Then the next structure will be, here we will get a new bond, this bond will be same, here we will have negative charge, and this structure will remain same. Next structure we will have benzene ring. Okay, this will move here, this will move here. So we will have bond over here, negative charge here, and NH2 with plus charge. Here this will be same, and then this will shift over here, and this will shift over here. So we will get the okay. Sorry, this will shift. Yeah, this will shift over here, and this bond will go on the nitrogen. So nitrogen will get its lone pair again, and we will have a benzene ring with aniline. So there are 5 resonance structures of aniline, which makes it more stable. Okay, so since it is having more resonance structure, that is 5, it is more stable. Okay, so more stable, meaning the basic character will be more. Okay, so this is about the basic character of amines in all aliphatic and aromatic amines. Okay, and along with the physical properties. So there are questions which comes on the basic character or basicity of amines, and also based on the pKb value. Okay, so pKb value means what? It tells you about the basicity. Okay, so here there is one statement regarding pKb value, that if pKb value is less, okay, if pKb value is less, okay, I will write it over here, smaller the pKb value, stronger is the base. Okay, so if you have pKb value small or less, then base will be stronger. Okay, so pKb is basically potential of the Kb value. If Kb means the constant of the base, ionization constant of the base. So if there is a question in which there will be pKb values given of particular bases, and they have told to us, they have told you to write the order, increasing order of the basicity, then you have to see that which is having small pKb value and which are having higher pKb value. Smaller the pKb value, stronger is the base. Lower the pKb value, weaker is the base. So it will be based on this. Okay, so here we will see one example. Methanamine. Methanamine means CH3NH2. CH3NH2 is having pKb 3.38, and ethanamine, that is CH3CH2NH2, is having 3.29. So in this, which will be stronger base? The stronger base is ethanamine, because it is having smaller pKb value. Okay, so this is about the basicity of amines. In our next video, we will learn about the other chemical reactions of amines. Okay, so yeah, thank you.